थैंक यू फॉर वाचिंग आवर वीडियो। प्लीज़ कीप कमेंटिंग कि आपको वीडियोस कैसे लग रहे हैं और नेक्स्ट वीडियो आने तक। Hello friends, welcome back to our YouTube channel. Today we're going to talk on a question that is in an Olympiad for 10 marks, right? So let's see what is the question. The question is, when a ball is dropped from some height, and when it is dropped, we are saying this means that the initial velocity will be 0, right? And it is a drop from some height, so we consider air friction. So let's see, if we say there is earth, right, and a small ball is at some height, right, and it is being dropped, and there is an air friction. So what happens is the initial velocity is as it is dropped, it is given as initial velocity is 0. So now if we consider air friction, right, we consider air friction, this means now the ball will be having two forces, right? First force is in downward direction and the other force will be in upward direction. Now how these are what are these forces? So let's see, if we say that the gravity will attract, right, the ball towards itself, the earth will attract the ball towards itself, and there is the second force, that is air friction. If we say this force of air friction, this air friction, what it is doing is it is stopping the ball to go in downward direction, right? This is what air friction does. So the net force on the ball will be F net is equal to force of gravity minus force of air, right? Now this is F air, right, that is gravity, that is air. So F net is Fg minus Fa. Now this friction of this force from friction or air is actually directly proportional to the velocity of the object. So this means that as a velocity changes, this force also changes. We can take any, generally it is Vf is directly proportional to V, but it is not limited to this. It can be V to the power 2, 1 upon V to the power minus 2, it can be anything, right? But in general cases, when the velocity increases, the force of friction increases on it, right? It can be 2, it can be 3, it depends on the medium actually. But as we have taking it as air, generally it is V to the power 1, right? That is why we are saying friction is directly proportional to V, right? Then force of friction is equivalent to if we take a constant, then it will be kV, right? We all know Fg is mg, mass into acceleration, right? So when we say F is equal to mg, right, so F net will be equal to mg minus kv. Why mg minus kv? As we have already seen that Fg is in downward direction and force of air friction, the friction by air as a force is in upward direction, right? So now we can say F net is equal to mg minus kv. Now if we proceed by this, we can say F net is equal to mass into acceleration. It is the second equation of motion. By second equation of motion, we came out to this equation m into a, and that is equal to mg minus kv. Now what we need to find out is v as a function of time t, right? So let's say first acceleration will be equal to mg minus kv upon m, right? Acceleration is mg minus kv. Now if we solve it, we can write acceleration as dv by dt, because acceleration is change in velocity upon change in time, right? Mg minus kv upon m. So we will get this acceleration, right? Now if we simplify this, actually we will take mg minus kv, this term in denominator with dv. So we can write dv upon mg minus kv is equal to dt upon m. right? Now what we need to do, we need to integrate it, right? So let's integrate it. Just a second, I just scroll it up so that would be easy, right? Right. So now, so dv upon mg minus kv is equal to dt by m. Now if we see, so integrating, this is, let this be first equation, right? So integrate equation first, right? So we know the integration of this, it will come out to be minus 1 upon k into में ln mg minus kv, right? I've directly integrated it and put the limit. So the initial velocity is given as 0, and at time t there will be velocity v, right? Is equal to the integration of dt is t, and this is m, and the limit of t would be from 0 to t, because we started at t is equal to 0, right? What is the property that we have used? So when we differentiate 1 upon say this is we will take, say, b minus ab a x, we can say, into dx, and we integrate this. So the property will be ln b minus ax divided by a, right? This is the property that we have used for integration, right? So let's see, I'm just sticking to all this together, right? Okay, so now let's see. So if we put the limit in this, in the place, so minus 1 upon k, right, ln, well, we put v, it will be mg minus kv minus ln mg minus 0, right, is equal to t minus 0 upon m. So in this, what's the property that we have used? We have actually integrated it. We have put the limits. Actually, after integration, we have put the limits. After that, what we can do in this is we can use a property, say ln a minus ln b is equal to ln a by b, as this is the logs property, right? So what we will do is 1 upon k, and we will write this as dividend divide. So mg minus kv divided by mg, right, is equal to t by m. Now we will take this term to our right hand side, so we can write ln mg minus kv divided by mg is equal to minus kt by m, right? We can take antilog. So now we'll take antilog. So it will comes out to be mg minus kv divided by mg is equal to e to the power minus kt by m, right? So we can solve it as 1 minus, we have segregated it. I will just do it properly so that you will not have any confusion. So mg minus kv by mg is equal to e minus kt by m. So mg is cut by this mg, and 1 will come out, right? Now we will take this my negative side to the right hand side and this k in the left hand side. So what will happen is 1 minus e to the power minus kt by m is equal to kv by mg, right? Now when we see, so this is the equation that we got. So now now we will take this term, this whole term to the right hand side. So what we can write is mg by k 1 minus e to the power minus kt by m is equal to velocity, and this is the function that we required, v as a function of time t, right? We can also find in here acceleration as a function of time also. What we need to do is we can just differentiate this value, right? When we differentiate it, see, so with respect to t, right? Why t? Because acceleration is a dv by dt, right? So mg by k, differentiation of 1 is 0 minus e to the power minus kt by m. So the differentiation of e would be a constant as it is. Now we will differentiate the above part, which is this one, right? So when we differentiate this, the value comes out to be minus k by m, as differentiation of t would be 1, right? So this comes out to be and v will become dv by dt, and it will become acceleration, as I have already explained in here. So what happens is mg by k minus will cancel this minus sign. So e minus kt by m into में k by m. So m will be cut from this and k will be deducted from this. So hence the acceleration in terms of t term would become this into g, right? And this is our answer. So we have got two values, right? What we have got is, first we have got v, and then we got a in terms of t. First we got v in terms of t, and then we got a in terms of t. So now we got two equations. First was the vt relation, and then an at relation. Vt relation we got is mg divided by k, 1 minus e kt by m is equal to v, and the at relation I've got is g e to the power minus kt by m. So these are the two equations. Now we can also see the graph of the vt curve, right? We can also see the graph of the vt curve. Just a second, we just take the space. So for vt curve, right? So now if we take a graph, right, we try to make the graph of say this is the v axis and this is the t axis. So what it says is, after initially when the time t is 0, right, say when we place this, so the equation is v is equal to mg divided by k, 1 minus e to the power minus k. Now time is 0. If we put it 0, then this whole will become 0. Something to the power 0 will become 1. So what we can say is mg by k, 1 minus 1 is 0. Hence at t is equal to 0, velocity is also 0. So the starting point will be this, right? As this time increases, right, the graph will actually hold like this, and then the velocity becomes constant, right? This is the graph that it follows. And thank you for watching. Best of luck for your exams, right? Thank you. So this is how velocity as a function of time vary in graphical manner and equations, right? So this is how the velocity of the object changes with a time graphically, and we have also seen it with the respect of equations also, right? So we'll meet again, right? Thank you. Best of luck for your exams.
थैंक यू फॉर वॉचिंग आवर वीडियो. प्लीज़ कीप कमेंटिंग कि आपको वीडियोस कैसे लग रहे हैं, और नेक्स्ट वीडियो आने तक लर्न करें, लाइक करें, शेयर करें और सब्सक्राइब करना ना भूलें. बेल आइकन बटन दबाएं और दोस्तों में हल्ला गाएं.